Hello everyone. I'd like to shoot this quick video to fill a gap I feel exists in the do-it-yourself 3D print experience. I found it rather easy to find videos outlining how to build your own 3D printer from scratch, which all exceeded 30 minutes, and a few with minimal detail, mind you, that were in the 1 to 3 minute range, but my hope is that this tutorial will be 5 to 10 minutes in length. I even have a script to make it reasonably smooth. I'll outline for you exactly how I built my 3D printer, which I've named the BraggBot, along with all of my references. So the motivation. I decided to build a 3D printer after I was unable to build a robot because I had no structure. I wanted to build a robot for entertainment, and I purchased a BeagleBone Black to do this. 4 stepper motors. Here's an example of one of the ones that I purchased. A NEMA 17 stepper motor. And an Easy Driver version 4.3 board to drive it. This, typical for robotics. I bought the BeagleBone Black because I used it previously to instrument my telescope, and there were excellent tutorials on how to use the BeagleBone Black, specifically by Mr. Derek Maui. When I reference people, I'll have links shown and also in the description. Once I started, I realized I had no structure. So I went online and I found a company, makeblock.cc, that's their address, and purchased their basic robotics kit, which came in a bag something like this. While the aluminum robotics structure was cool, the cost overall was slightly unreasonable. After a bit of pondering, I thought, I have a BeagleBone, I have stepper motors, why not build a 3D printer? Hence the idea. Now that I had the idea, I needed to get started. I began by buying standalone things like temperature sensors, the motor that I showed you, here's the temperature sensors, and I figured I could cobble together my own setup and integrate it into the BeagleBone Black. After a few days of monkeying around, I realized that this project was going to be slightly larger in scope than I had intended, so I needed a cape to assist me. After searching Google in late 2014, I found that the only cape which was thoroughly designed and used, though not easily purchasable, was the BeagleBone by Bas Laarhoven. I quickly contacted him and purchased the cape. He's a really helpful person and super professional if you interact with him. Well, the BeagleBone arrived at my home, and I excitedly went to plug in some of the motors and get started. First, I used the machine kit image, which I found on Charles S., I won't pronounce his last name, page, reference as well. And then I realized, crap, these Easy Driver stepper motor things don't actually fit in the cape. So then I purchased the Pulleys A4998 controllers. They worked really well and powered the motors just fine. When running some tests though, I noticed that they weren't the strongest, and then I stumbled on a forum telling me that I needed more torque to successfully drive a 3D printer. And I probably would want higher microstepping. I'll get to why later. Well, after reading that forum, I upgraded my motors to the Kaisan 1124090 NEMA 17 stepper motors, which you can find on Amazon, and those have 54 Newton centimeters of holding torque. Quite an upgrade from the previous stepper motors, and version 3 of the stepper motor controllers if you're counting. The new controller that I used was the DRV8825s, also by Pulleys, which has 32 time microstepping, which is what I needed. So now I had the computer, the BeagleBone Black, the cape, the BeagleBone++, the motors, the motor controllers, the DRV8825s, and the software controlling all of this, machine kit image running Linux CNC, which you can see right there. So once the software and electronics were ironed out, I got started on the structure. I wanted to design my own Delta robot, 3D printed from scratch. Why a Delta robot? Well, because the BeagleBone++ natively only controls 4 stepper motors, and I was too cheap to buy the add-on. And I'm happy this was the case because I believe that a Cartesian one is the route I would have gone. And I honestly think I'm a bigger fan of the Delta robot design just because, 1, it looks a lot better, and 2, I like the fixed build platform. My wife also appreciates the appearance of the Delta robot versus our Cartesian-based one, which would have looked a little clunky. I watched a ton of YouTube videos on other people's designs, and I found Mr. Warner Berry with the BraggBot, you can see where I got the name BraggBot from, to be the most informative. I was able to watch his videos, particularly the one about his end effector, which he was holding in his hand in the video, and I used him for inspiration in my design. Simply by seeing him hold his end effector, I was able to reverse engineer that in a program, FreeCAD. Now I must admit, I'm not a mechanical engineer, so I have very limited CAD experience, but the all-knowing YouTube provided you with plenty of tutorial content, also referenced. After watching about 1 hour of videos, I was able to design 95% of my solution in 3 days. I designed the major components around the make block structure because I thought it would be convenient to have universal components while minimizing the parts I needed to have CNC for me. From the beginning, I decided I want an all-metal 3D printer because I thought it was cooler, and I don't have friends with a 3D printer to print me parts, so I kind of needed that. Once I had my design locked down, I utilized my friend Jay and his 5,000-pound CNC machine to make everything you see in silver except for the sliders and the rails. Things like an adapter for the motors, something for my hot end to screw into, even the attachment on the sliders, but not the sliders themselves. He has a CNC machine that goes to 1,000th of an inch precision. You can use him. I'll have an email address for him in the comments below. I don't care. I don't want anything to do with it, but he's who I use. And he probably will charge you something. So finally, all my parts arrived. I used MXL cables and big pulleys because that's what I had in the first robotics kit that I bought. I feared I would not be able to get good prints because everyone raves about the GT2 pulleys and cables, but I figured with me using 32-step microstepping at 92th on my pulleys with MXLs, I was able to actually get 35 steps per millimeter, and I figured that would be fine for what I was using. And you can do those calculations either yourself or use the calculator for your steps per millimeter on the Prusa website. For me, I typically print at 0.3 millimeters. I can probably successfully go down to 0.1, but I have no reason to do that because thinner layers just mean more print time for me, and my prints are turning out just fine. Assembly was not problematic because I first designed the entire thing in FreeCAD, so everything fit as designed. One thing I would point out, if you're not a mechanical or an engineer or designing mechanical structures often, you want to be sure to account for screw head thickness. I barely had clearance on many of my things, which is pretty scary. So once the printer was assembled, then came the end effector. I used chrome balls JB welded onto the end effector and the sliders. That seemed to be the best idea as I saw it all over the internet. Well, I don't know if you noticed when I held up my end effector, after a few days, one of the balls actually broke off when I was running the printer. So then I found Hayden, who I am going to reference below, and I'm going to show a picture of what he provides on Thingiverse, and I bought his ball joints, which are threaded with M3 threads. They work fantastic. They were only $1 each, which was the cheapest thing I bought for this entire thing. I bought 18 just in case, and I only needed 12. Actually, all of them were great. It was easy to hacksaw the threads off to the length that I needed. Speaking of things going wrong, I also bought polycarbonate rods for the end effectors, and these flex quite a bit. So while the polycarbonate is good for enclosing the printer, it's not good for the arms. So then I went and I bought steel rods, and those were far too heavy. So they would not work, so that was fail number 2. So finally I found McMaster Car, and I paid a reasonable price to buy carbon fiber rods. And these don't flex, or at least they don't flex at the lengths that you would need for the arms. I also bought standoffs from McMaster Car, which were a little big, and after I was able to get the 3D printer successfully working, I printed the orange standoffs that you can see there, and they also enclosed the magnets. So I guess the 3D printer prints something for itself in the end anyways. My advice to you, just buy the carbon fiber rods from the very beginning, even though they're a little bit expensive, so you don't go through 3 sets of rod and waste even more money. Now for printing. I print in ABS because I like it's the same material as Legos. I like how it won't melt in my car in Southern California heat. And if I leave it, it's going to be fine in there. And also I like it because it has less friction than the PLA, so it won't get jammed up in the hot end as much. I was able to print a test cube my first try without any issue. At, I think it was 29.85 millimeters for 30, which was reasonable. All I had to do was spend about 1 hour learning how to calibrate my printer using a method outlined by the other Bas, Dave Gruen, and the machine kit Google Group. Once I got it calibrated, I was able to print like a champ. I print on the CNC heated bed at 102 degrees Celsius. I used ABS juice, just ABS dissolved in acetone. To adhere my prints, I started off with hairspray, the Aquanet Super Extra Stronghold or whatever. Then I did the purple glue stick, and for me, the ABS juice works best. and that works good for my small and big prints. For the extruder, I use the Easy Extruder, also from CNC. For the hot end, I use the B3 Innovations Pico, 1.75 millimeters, running at 232 degrees Celsius. And the ABS that I use is Prototype Supply, found on Amazon. It's a little expensive. I think it's $40 a roll, but it tells you the printing temperatures. It comes in a nice box. It unspools very conveniently. So I must admit, I don't have problems printing. The diameter is consistent and unspools well, and I don't actually smell anything. So people say ABS stinks, maybe it's because they're using poor ABS. The programs that I use to slice all my parts that I get on Thingiverse or that I design in FreeCAD is Kiss Slicer, the second beta version I think it is. Other than that, you can look on YouTube to find out how to configure all the software. So anyways, hopefully this short video with lots of references and lots of pictures inspires you to design your own 3D printer. If you have any questions, post them below and I will answer.